Okay, Yorick, the Fronius Reserva battery has hit the market. So this is a 2025 edition Fronius product. I reckon surely this has got to be the best battery on the market by far. And in this video, I'm going to tell you why it's so much better than the BYD.
Is it though? I reckon it missed the mark.
Well, let's debate that, eh?
Let's debate.
Okay. Okay, Yorick, I'm going to start on a high note, at least for me. So the Fronius Reserva battery, you've got to admit, it looks so much better than this old clunky thing from 2020.
I'll give you that point, Mark. It is a very nice looking battery. It's very sleek. It matches the Fronius colouring really nicely.
And it's got a big, sexy Fronius logo on it too, you know?
Yeah.
You've got to love a bit of that.
Yeah, but look, I give it that. It's a nice slimline battery. I like the fact that it's got a stated charge indicator on the front of it. It's nice and slim in comparison to the BYD. It's definitely a good-looking battery.
And you know me, Yorick. I've always been a fan of these little plastic clip-on covers.
Well, I mean, I haven't been personally. I like my BYD because it is all metal.
Yeah, no. So we famously or infamously had a crack at Sig Energy for their plastic flimsy covers.
Yeah.
They are plastic flimsy covers. I got to admit, this is better, but not a whole lot better.
Yeah.
I don't even know why they put plastic covers on. I think they didn't need to. There's nothing wrong with a bit of,
To be fair, I mean, they're not covering any sort of thin UV, exposed cables, but it is purely decorative in this case.
Yeah, so decorative and a little bit annoying for installers getting this straight. We've chucked these on here, and if you look closely, there's sort of gaps around them and stuff as well. So not the greatest move by Fronius there, but I've got to say, it's still better than the Sig Energy cover, which...
Sure. Well, you can keep on going on about how great your plastic covers are, Mark. It's all well and good when you have no stickers on your battery. I mean, I have to have these ugly stickers all over the place. So what do you got? What's going on here?
Okay, now you've started me on my bandwagon. So for a while, we've been making our own labels, right?
Well,
because this is the kind of crud that you get from label makers, these big danger stickers. You don't need these stickers on your batteries. And you see, jump on Facebook, any solar page, and you'll see these batteries that people are showing off with like 15 stickers all over it, and they're so proud of their stickers. These stickers are garbage. They're not going to last. They're not needed because you haven't put your thing in a battery.
careful, Mark, one stick.
You don't need like 25 font labels. So this is the biggest label that we've got. You do need one big 170mm or whatever it is label.
Yep.
Don't put it on the front of the inverter, just put it around where no one's going to see it except for the inspector, because nobody cares about these labels anyway. There is a shutdown procedure that we do need, but you make it specific to exactly, the switches on the right side or the left side or whatever it is. You make it specific.
And we've got one that's up on the BYD here. It's nice and small and neat.
Yeah, so put it on the front somewhere where the customer can see it, or even on the side if they're going to approach it, because they will need that label. There's a couple of other little tiny labels that we need, and labels that we can put on the side of the inverter. But please stop doing the label graffiti.
And use ones that last. These are really solid in comparison.
Well, yeah.
These will last the test of time. And that's really what's important.
Yeah, you have this flimsy little sticker is just not compliant to the Australian standards the way it's written anyway. And we honestly do not need 20mm font, 10mm or 6mm, I think, is the requirements depending on what it is.
It's all in the standards anyway.
Anyway, you got me started, but I'm going to get off that high horse.
Oh, well, I'm going to get onto my high horse. So, Mark, my battery can stack up to 22.1 kilowatt hours on 3-phase and 19.3 on single phase. How big is your battery stack?
Yeah, bragging a little bit there. For single phase, this is really where the Fronius Reserva missed the mark. Maybe fine for the European market, but we can stack 9.5 kilowatt hours in one stack on single phase.
That's not very big.
Which is not, we can do 2 or 3 stacks.
Yeah, but I can do that in a single stack.
Yeah. So it is kind of missing the mark. And the problem with having to do multiple stacks is you have to buy multiple BCUs or BMUs, which kind of just starts tipping the price out of there where, BYD doing one big 19 kilowatt hour stack. Is that probably what you're selling more of?
Yeah.
That's a single phase?
Definitely for single phase. I think the BYD is where it's at, but it's a bit of a 50-50 on 3-phase, or maybe even a bit more in the Reserva favour for 3-phase applications.
Yeah.
Because we could do a 15.8 kilowatt hour Reserva stack, which is not huge, but when you can stack one in front of the other, it's a very compelling offering.
Yeah, all of a sudden you've got 30 kilowatt hours or 48 kilowatt hours of battery in one neat little area. Fronius came out because they realised that in the Australian market with this rebate, everyone was going to want 30 and 50 kilowatt hour batteries. They came up with a design that we stacked them in front of each other with brackets, Still an air gap there, which is important for cooling.
Good cooling is
But
important.
you can stack up to 4 stacks out. 3 stacks is all you really need, isn't it? So
Yeah, I mean, look, with the BYDs, I can only have them stacked side by side or vertically. So, there is a little bit more of a limitation compared to the Reserva's flexibility.
yeah, sure. Okay, now let's move on into energy density. So we're talking about how many kilowatt hours, how much storage you can fit into one little container.
Well, talking about little containers, we've actually got some the modules on the table with us. So my BYD is a 2.76 kilowatt hour battery.
Yeah, okay.
And
2.7. This beats at Yorick. It's a 3.15.
Oh,
huge.
Yeah. Well, yours is definitely a bit thinner than mine,
Yeah.
and I would say even a little bit more energy dense. So these are both LFP battery chemistries, and this is a 50-volt module, and that's a 100-volt module.
Yeah, okay. So let's talk about the cells that make them up, right?
Okay.
So we went and bought a bunch of cells just so we can get our head around this.
Yep.
This is a 30 amp hour cell, and we have 32 of these cells in here.
Yep.
So each cell is 3.2 volts. So 30 cells, and we get 104 volts or something like that when we put 30 of these or 32 of these together in one cell. So that's why it's a 100-volt battery.
Yep. Well, I've got a 50 amp hour cell, and I've got 16 of these in this module, and that's what gives me a 50-volt battery, and that size.
Yeah, okay. And 16 times 3.4 is about your 50 volts or
About
something
50
like
volts,
that.
yeah.
So, yeah, that voltage part of it is kind of interesting, and maybe we get onto that a little bit later. But so energy density, let's talk about, because you came up with an interesting way of talking about this. There's different ways of talking about energy density.
Oh, well, there's the weight, or in this case, I think volume is really important. It's just sitting there. We're not moving it around. And so how dense the battery is, I think, is what a lot of customers are curious about. How much space is it going to take up?
Yeah.
And so we're doing some maths, and I have to admit, my BYD doesn't do so well in this front. It takes up about 14.8 litres per kilowatt hour.
14.8 litres.
About 15, yeah.
Per a kilowatt hour. Yeah, okay. So mine's a little bit better than that, a little bit more energy dense. You would hope it gets a little bit more energy dense as time goes on. Mine is 10 litres per kilowatt hour.
So
that makes it better.
Yeah. Smaller is better in this case.
Is it? Well, let's talk about our friends at Sig Energy. This fella here.
That's a big battery you got, Mark.
This is a 320 amp hour, 325 amp hour cell.
Yeah.
Multiply that by that 3.4 volts, and we're at around about a kilowatt, or I think 1.1 kilowatt hours of storage in this. So it would only take 9 of these to do Sig Energy's, what they call the 10 kilowatt hour battery, right?
Correct, yeah. But I mean, these cells are often used in
8 of these, actually.
But these cells are what's often used in industrial size battery systems or grid size battery systems where there's a lot of active cooling. And this is something where we have a bit of a concern about some of these battery systems, is because it's meant to last the test of time. Having something that's less energy dense, has got a lot more surface area, it's a lot more able to be passively cooled. And so I think this is one of the things that, both the BYD and the Fronius do really well, is these batteries are really under no stress. We're not charging them really fast, we're not discharging them super fast. And they're really going to last the test of time.
Yeah, so it's a combination of two things, right? Is that the cell itself is less energy dense. So I need 11 of these to make up one of these. But if we try to stack that together, and it would be up here if we kind of put them all together, so it would be a much less energy dense cell for 11 of these. It's not only that, but it's how tightly you cram these in together and jigsaw puzzle them together. And they haven't crammed them in. A lot more surface area on this and surface area on the whole battery as a whole for that cooling. And cooling is everything when you're talking about longevity.
So about 15 litres a kilowatt hour, about 10 litres a kilowatt hour. What is it for a Sigma?
Sig Energy, you crunched these numbers, 6.3, I think we've got there.
Yeah, it's including the BMU.
Including the BMU, yeah, that's right. So not all the DC to DC converter on the side.
Oh, yeah,
right?
the optimizer.
Yeah, exactly. So Sig Energy have really crammed it in. I just don't know it's a great idea. I reckon the winner here, if I'm going to put my conservative hat back on, is go BYD. Is that they just haven't crammed in.
I'd say proven reliability might be a thing, Mark.
Yeah, we'll get on to proven reliability in a second, eh? Now, when we're talking about heat and heat loss and everything like that, this is something that I've wasted far too much of my life on.
We're actually doing some testing on the Anchor battery at the moment, as we speak.
Yeah, so we're doing round-trip efficiency testing, and I've done it on a whole heap of batteries, and we won't go into that fully here, but we'll explain it really quickly. So round trip efficiency. So let's just say I put 10 kilowatt hours into a battery, taking it from the sun. We talked about this last time. How many kilowatt hours in best case scenario am I going to be able to draw out of that?
So I've actually looked at the figures this time. We get around about a 90% round trip efficiency in best case, so about 9 kilowatt hours out if we put 10 kilowatt hours in.
Now, best case scenario means that we're charging it pretty fast. It's more about the inverter efficiency. So if we charge a battery at 50 or like 5 or 10 kilowatts on a 10 kilowatt inverter, it's going to get around about that 90% efficiency.
Yeah, but if we discharge it really slowly, well, then we have a lot more losses.
Yeah, the battery loves being discharged slowly. There'll be no heat loss. But the inverter hates being run at 300 watts when it's a 10 kilowatt inverter. So that's exactly what I did. I charged it up really fast, or whether the battery and the inverter were both happy. You know, it wasn't too hot for the battery.
To simulate like a good sunny day?
A good sunny day, yeah. And then to simulate overnight where your fridge is running and you're getting standby power, I did, and it depended on the test I was doing, but around about 300 watts of discharge. Yeah. So the best case condition charging, worst case condition discharging, averaging it out, and the efficiency that we got on both of these batteries was
around 80% in the worst case scenario.
Yeah.
So that's, you know what, still pretty good.
Pretty good, but I was surprised actually, because I've asked a lot of people in the industry what they thought these figures were going to be, and they were kind of like what I thought originally, is sort of 95 to 90% efficiency.
Okay, that's interesting.
In the real world, but no, we're down at 80%. Or now, what about
60% sometimes?
What if we're talking about these bigger cells that are heating up and less efficient systems that are out on the market that aren't using this high voltage architecture?
Yeah.
We'll get into why that is important after this.
Sure.
We're down at something like 63% efficiency.
Yeah, so I'm very interested to see how the anchor performs actually in this case, because we've seen some very wide swings in terms of the round trip efficiency of these products.
And I've said this before too, Yorick, but I don't know, efficiency isn't the most important thing. If you've got a 30 kilowatt solar farm on your roof, you know, if you've got unlimited power up there, then maybe efficiency isn't important to you.
Look, I think efficiency is good all around. The more efficient we can make these products, the less losses, the smaller these systems can be, but also the less heat generated and the less chances for things to cook.
Yeah, and heat generation is battery degradation, right?
Yeah,
batteries hate heat, so running it efficiently is just a longevity thing, not just an efficiency thing.
I completely agree on that.
High voltage architecture.
Sure,
we've been sort of alluding to that. Why is it so good? Why do we like high voltage batteries?
So there's a few reasons why high voltage batteries have an advantage, and one of the reasons these battery systems are so efficient and also generate less heat. The currents run at a much lower current, which is good. Inverters want to run at around about 400 or 800 volts, depending if it's single phase or three phase. But when we're running, if we've got a 50 volt battery that we have to bring all the way up to 800 volts, there's a decent amount of efficiency loss in that. Whereas if we have a stack of the BYDs, it's going to be sitting at around, let's say, 8 modules at 50 volts, 400 volts, or 5 modules at 100 volts, about 500 volts. This is much closer to the inverter's happy operating range, and so it's a much more efficient system.
Yeah, so it's a matter of having these smaller cells. We get to string in series a whole heap of these together to naturally get to that 400 volts, so we don't have to have this boost stage, which just loses heat, loses efficiency.
And it's a point of failure too. I mean, the less power electronics you have, the more reliable it should be.
Yeah. Now, we've kind of talked a bit about energy density and the fact that this is crammed a whole heap of density into it, and that my battery is more energy dense than your battery.
Yeah.
Now, how relevant is that in the real world when it comes to putting it in your garage?
Look, space is always a premium in a garage. Look, cars got to fit in there. We've got to have clearances from windows. And look, I've got to give the point to Fronius on this one, especially for the three-phase applications. If I want to have, say, 44 kilowatt hours, so, sort of a big system to make the most of the rebate, I need 2 stacks of 22 side by side. Well, how do you do it in your case, Mark?
Yeah, so I can just do 3 out. If I want to, just do 3 stacks in front of each other. So we can, like we said, we can stack them in front of each other. So we're just taking up much less wall space. What are we taking up? 800 mil of wall space.
But it sticks out by about 700?
It sticks out by 700. So if you can sit a fridge in the corner of your garage, you can sit one of these batteries in the corner of your garage too.
Yeah.
But let's say you don't have that, but you've got plenty of wall space. Well, I can put, 3 stacks out along the wall, and I've still got plenty of space to open my car door. So.
Whereas in the case of the BYDs, we have to sit them side by side. We can't sit them one in front of the other. So I need about 1.5 meters worth of wall space, but it's always going to stick out by about 35 centimeters. So yeah, less flexible in my case. But
yeah, so it's not so much about the energy density per se. It's more about the flexibility of that footprint that how it works in our garages, you know. So yeah.
I agree.
Now, there is something to be said. We've mentioned SIG energy, right?
Yeah.
And there is something nice, you've got to admit, about having one big fat stack, 48 kilowatt hours, whatever they come up to, and done and dusted, right? Yep. So there is something elegant about that solution too.
There's a reason they're very popular, for especially with the rebate and how it's sized. So, well, look, we've spoken about energy density, efficiencies, sizing. Well, I think I need to get one more point on BYD side, Mark, and that's charge and discharge rates.
Yeah.
So with the BYDs, especially on single phase, because we can do these bigger stacks, we actually get slightly faster charge and discharge rates. Now, this is important if you're doing full home backup or also virtual power plants or VPP connectivity. So, if you're in a situation where you need to be able to dump lots of power into the grid quickly, or let's say you're in a blackout and you just want to have a lot of headroom so you don't accidentally trip the solar and battery system, if you accidentally turn on the aircon, having a high throughput is important. I mean, on three-phase, it's important too, especially because, it's the per phase output. But basically, on the BYD, I can get up to about 7.9 kilowatts out of that battery on an 8 or 10 kilowatt machine. But because we can only stack these up to 9.5, I can only get 6.75 kilowatts out of that battery on single phase. So not a huge difference, but for me, that's important.
Look, I was starting to glass over there. I do this for a living, but you do it every single day, talk these numbers to people. There is something to say about battery design, right? And you can get a cheap battery, you can chuck it in. Yorick, you could probably do a really good job at designing a cheap battery for a customer and getting what they want, So, having that charge and discharge rate suitable for what their home need is. And maybe that's not important to them. Maybe they're not worried about VPPs or blackouts. They've got other requirements, the spacing, the sizing in the garage and things like that.
Well, these are long-term investments. I think this is where talking to a consultant such as myself or one of my colleagues is really important, because we want to have a holistic approach and really suit the battery to your needs. It's not a black and white approach.
It isn't. And, the best thing about it is if you do it properly, you won't get these stickers all over your battery, which is, I think that's important. Yeah, anyway.
But look, on that topic as well, while I think the BYD is a fantastic option for single phase, for three phase, the Reserva is a really good option as well. You actually do get quite a high throughput, especially on the 15.8. So it's, 100%. It's very much case dependent.
So I think this is what I like, that BYD have kept partnering with Fronius. By the way, BYD are bringing out their own inverter. And so they're going to stay in the market solid. That partnership is going to last with Fronius.
I'll be doing a video on that soon.
We're going to get one to test, and that'll be pretty cool. But what I do love is that now we've just got more choices. We can be really flexible in whatever the customer wants with this Fronius solution, and you still get the best inverter on the market.
Yeah, and actually soon we'll have the Verdo Plus as well, so that'll be very exciting, and I think we'll have a video on that as well. Yeah,
okay. Now, I do think I need to admit, though, I concede that I reckon Fronius kind of missed the mark on this. For a product from the premium brand in the Australian solar industry, this is really a European product. There's some advantages to BYD in some of the design and some of the layout and stuff like that. But I was really hoping that this would be head and shoulders above everything.
Yeah.
More flexibility and things.
Yeah. My thoughts on it was if you're bringing out a product for an inverter that you've got on the market, it needs to outperform a third-party battery. And I feel like if you bring out a battery that can't quite outbeat an existing product, it's a pretty hard sell.
Yeah, and I got to say, it's going to sound like you're winning this, but I do love the Fronius battery still. But the BYD, we've been doing this for 6 years, right?
Oh yeah, and they've been rock solid. I think apart from a couple of BMUs, which is this dark component being dead on arrival, I don't think we've had a single battery module fail.
No, we haven't. We've had a couple of BMUs. That's right, but no batteries at all that I've been aware of. It'd be interesting to know if anyone's had battery module failures. I've heard of some installers installing these wrong and screwing up the battery module, but that's the installer's fault.
Yeah. I mean, look, to be fair, in the 2 months we've been installing Reserva, we haven't had any faults yet either.
Right, not a huge track record, but anyway.
Time will tell. Oh, I forgot to mention this cover. What is it, Mark?
Yeah, okay, so this is our BYD cover for the cable cable guard or whatever we call it. So how this came about is BYD had the ability, our cables going into the top of it, the BMU, could go into conduit. And then all of a sudden, they decided to change the design on us, and we rock up on site, and we had to plug MC4s into it.
Okay.
And then installers call us up, and they're like, this is ugly. This is a premium product. And we got 8 cables and all sorts of things and data cables coming out, and it just looked terrible.
What's wrong with that, Mark?
Yeah. Well, it's premium product and we don't like things to look ugly. And I'm thinking too, that's just dumb. Yeah. So I looked up the standards. I tried to find a justification for why that was dumb. And it turns out it is. Here's the reason why it's dumb, right? Is that inverters, your solar inverter that's connected to the solar panels on your roof has basically the same cable or exactly the same cable plugged in, but the short circuit current of the panel, the highest current that can flow in a fault condition is about 15 or 20 amps or something like that, right?
So not huge.
Yeah, so pretty low. What do you reckon the short circuit current, the maximum current you can get out of a battery if it's faulting?
Or I'm going to guess 100 amps.
Yeah, like 5,000 or 10,000 amps, right? Way more than that, right?
Yeah.
So you don't want short circuit current happening. So let's say, I don't know, you're pushing a wheelbarrow, pushing a mower or a trolley and you accidentally braze against that, or your kid's throwing a spear in the, or something
or your bumper just with your arm and walking by. Yeah.
Yeah, it'd have to be fairly, they're hardy cables. But anyway, Australian standards say that DC cable from batteries has to have a level of mechanical protection. So, yep, we designed this and printed it up. Turns out the week after we had designed that, we were heading off to BYD.
Well, yeah, we've got some photos of that, actually.
Yeah, so we went over and showed the engineers our design. They asked for the drawings, and they've made basically exactly the same cover for the market, which is pretty cool that we had a bit of a say in the R&D of BYD. So I think a big thing about this is I've been pushing other inverter manufacturers who are getting this wrong. Installers are getting it wrong because they're just installing it the way that it was designed. Other manufacturers need to get on board and start making these covers so that installers can do the job compliantly without doing stupid things like getting air conduct or putting monsters, corrugated conduit over the cables and making it look like a disaster.
Yeah, I completely agree.
We do need this mechanical protection around your DC cables.
So the plastic covering on the Reserva isn't just decorative, it's also functional.
That's right, exactly. Same with SIG Energy, right? They got it right at least. I didn't love that plastic cover, but at least it is doing the job in protecting that DC battery cable.
Well, I think in conclusion, it's not a black and white answer. Both have their place. They're both really good batteries. I'd happily recommend either of them depending on the situation. And, they're both a fantastic options you should consider.
Definitely. And like we said earlier, we're testing all sorts of batteries in the future. So follow for that. We're getting some really interesting results and can't wait to get the results from your in-laws.
Yep. And I think we've got some more battery and inverter reviews coming out soon. We're doing a trip to China in about a month. So we've got more in the works there. So
that's right. Thanks, Joz.
Thanks, Mark.
Okay.
See ya.